Greetings again, Cantaloupe here. I'm going to show you how to make a deformation system that operates on a three-dimensional object or grid in HTML5 canvas. This is a standalone video. You don't need necessarily any other videos, but if you prefer to see how it gets set up with a responsive shim, there is a tutorial for that as well. So I'm going to jump right into the video. Here we go. Alright, so my aim here is to create a grid, but not an ordinary grid made out of squares or vertical and horizontal lines per se that you might have seen on like graph paper. This is going to be a hex grid, so there's a bit of a trick to it. I use these sometimes just to be aesthetic, to be kind of visually pleasing. Hexagonal grids are a little bit of a challenge, just slightly more than a normal grid, because you're doing some spacing and a little bit of math behind the scenes just to make it all fit together. So that math, in a nutshell, is, and you'll see on the screen, each cell is drawn separately. It's not a single line that's making up the whole grid, or even a group of horizontal versus vertical lines. It's a collection of hexagons, obviously. So each row, and maybe this is obvious, but each row is offset by a half. So your first row is going to have a hexagon with a half space in between it and the next hexagon, however many you want in that row, however many columns that's going to be. It's a way to think about it. And then your second row, or the next row, is going to be the same thing, just offset by 50% of your spacing. So, and that's so that the hexagons can all mesh together. And you'll see here pretty quick that that is what happens in fact. So, once the hex grid is put together, and I have a couple of variables to control it, that is the size of the cells and the number of cells, the rows and columns. And then I add a modifier that I use sometimes for this type of animation, for a hex grid especially. It's a distance check. Now, if you're familiar with trigonometry, you know about the hypotenuse, which is super handy for checking distances, and honestly I'm not sure how else you would do it without it. So what you do is you take 1 point, and this works in 2 dimensions or 3 dimensions, or even 1 dimension, I think, and you check the hypotenuse between those 2 points. If you visualize a right triangle, either, it doesn't matter which way you go, the hypotenuse is the same length, whether you're going down into the left or up into the right. It's a right triangle with the same hypotenuse, and the length of that hypotenuse is the distance between those points, of course. So with the distance check, I'm going from the center. It's called the origin in your environment, in your digital environment, your three-dimensional space. The coordinate 0, 0, 0 for x, y, and z is called the origin, and I'm checking. It could be, the distance could be relative to another object. It could be relative to any arbitrary point. But for this animation, and for many of my animations, I just check the distance to the center. And if that distance is less than some number, you'll see here I have my grid, which was formerly rectangular, is now circular, which is kind of cool. So I have a circular hex grid. It's actually a rectangular hex grid that's been trimmed to look circular. It's just omitting the hexagons that would have been overlapping or overflowing that perimeter, that radius. So I'm moving on to the actual deformation of the grid. The grid is completed, and I'm messing with some stuff. Sometimes in my animations I'll do a little bit of explorations, and I'll have a loose idea of what I want to do, and maybe a certain percentage of improvisation goes into it as well. Right now I'm doing a formula which is based on the same thing I just described, as the distance to the center, but I'm varying the height of every vertex in every hexagon by the sine of the distance to the origin. I'm sure I'll say that again. I'm varying the height, or the vertical position of every vertex in every hexagon by the sine of the distance to the origin. Maybe math can get pretty dense. That's why we have a special notation just to describe math, and that is math. It's literally just the math statement. So maybe the code speaks for itself. I'm using a variation of what I just described to also modulate the color, and I keep messing with it and fine-tuning it until I get something that looks interesting enough to call a finished product, or to move on to another stage, so to speak. So, and you'll notice it's animated. So I didn't explain that. So the function I just described, the sine of the distance to the origin, varying the height by that, I'm adding t in there at a strategic location. So t, remember, is our frame counter, or it's a time variable that's incremented once per frame by 1/60th. So it counts up at ideally one integer per second, 60 times a second. So t is an interesting thing because it's you can do things with it, add it to your formula, and you already know what it's counting up to, what its value is going to be. So it's kind of an intuitive handle. It's a control for the animation. I'm just adding some new stuff here. So I added the function I described, the distance function, the sine function, and I'm also adding the angle of that vertex, each vertex and each hexagon, the angle to the origin. So when you combine the angle with that previous function I just said, you get a nice spiral out of it. And you can actually make a double spiral, and what you'll see here shortly is I turn that single spiral into a triple spiral just by multiplying it by 3. That's a pretty it's a pretty simple thing to do. Fine-tuning the colors. You can spend a lot of time on the aesthetics of an animation, or I should speak for myself. I sometimes get pulled into it, and hours tick by, and suddenly, hopefully you end up with something worth your time. That's really the important takeaway, is make sure that you're not wasting your time. If you're learning something, perhaps it doesn't really matter what comes out of it. You've grown from the experience. So I try to make the most of every minute that I put into this. So if it seems to be going nowhere, sometimes I have to draw a line and say, okay, this direction wasn't worth my time, and I'm gonna just eat a few minutes and then regroup, and go in a different direction. So that doesn't happen very often anymore to me, because I've got to a point in my skill level that I have control over it, and you can gain that. Many people can, perhaps not everybody, I don't know, but it takes years to familiarize yourself and to get comfortable with a system, and it can be your own system or someone else's or a program, whatever. But you get to a point where you drive, and I remember when I first started doing this stuff, I was not necessarily driving anything. I was just lucky if something pleasing came out, no matter what. But now it's much more intentional. Everything that I create is more intentional. So you'll see here, it's getting close to the end. It's almost there. It's almost at the goal, I should say, not the end of anything in particular, but I have almost finished the animation that I set out to do. So there it is. And it looks nice. I might add a couple more things, like a background or some stars or something. I have a style that I've been working on for a long time. So Hopefully that was interesting to you. I explained a couple of things that are going on in the program, and if you have any questions, as usual, feel free to reach out, ask me anything. And it's whitehotrobot@gmail.com. You can find my contact information all over the place. But that's the animation. And thank you very much for joining me, and I hope you have a great day. Thank you.